Today we'll look at how to set up a transient nonlinear multiphysics coupled thermal structural analysis. Here we'll create our simulation files in the Simcenter 3D multiphysics environment, and we'll create a thermal structural solution 401 with some nonlinear static steps. And we're going to create 12 of them for the 11 seconds that we're going to be running our transient analysis. So for our transient steps, our first step needs to be at time equals 0. And I've decided to take a 1 second increment for our steps, so we'll go ahead and edit the remainder of the steps to edit the end time to be 1 second increments from 0 to 11 seconds. All right, now that we have our steps set up, we'll go ahead and put a mesh on the part. And here we'll use the Hex Dominant Mesher. And I'm going to use a coarse element size for this demonstration to speed up the solve. So here you can see we have about 2 elements through the thickness. And I also don't need to apply a material property because by default I'm inheriting the material from the CAD model. Next we'll go to the sim and we'll apply our thermal load. We'll create a heat flux that will be transient, and we could make that out of a table-based field if we had discrete values at discrete times, but I'd like to put in a sine pulse for my heat flux. So we'll make that as a function of time. And we'll type in our function as being the sine of time times 360 divided by the period of our sine function, which will be 22. And we're only interested in the first 11 seconds of that, which will be positive. And here we can plot that just to make sure that we've got it right across the first 11 seconds. And that looks great. So we're going from 0 to 1 BTU per second inch squared. All right, next we'll put a convection to environment constraint on the remaining faces, and we'll assign a convection coefficient. And here I'm just going to box select all the faces and then hold down the shift key to deselect the bottom face and the whole. All right, so we'll go ahead and hide the constraints in our loads. And just to note, if you have a initial stress-free temperature that's different from room temperature, you can set that here. I'll leave that at 68 degrees. Next we need to assign some structural constraints. Because we're doing a coupled thermal structural analysis, we not only need thermal loads and constraints, but we could put structural loads and constraints on there as well. And here we'll fix one corner and put some user-defined constraints on the other 2 corners to simply support the part. And now we're ready to run. I'll go ahead and pause the video, and you can see it takes a little over a minute to run. And the results that we have now, because it's a coupled thermal structural analysis, are both structural and thermal results. So first we'll take a look at our structural results. We'll look at our displacement at the final time step, and we can animate those displacements across time. So here you can see how the part is deflecting as a function of time. If we want, we can plot the displacement as a function of time as well at a given location. Next, we'll take a look at our thermal results. So here at our last time step at 11 seconds, we'll take a look at the temperature. And you can see because the heat load was only applied for 11 seconds that the temperature hasn't really had much of a chance to propagate through the rest of the part. And here you can see the temperature evolution as a function of time, and we can also plot the temperature as a function of time at a particular location. And that is how to set up and run a transient nonlinear multiphysics coupled thermal structural analysis.